Now, since symbol table is a table, it is going to have the columns, right? And column names are also called as attributes. So let's see how does the symbol table look like, which means what are all the columns the symbol table is going to have. Now, each entry in the symbol table is associated with attributes. So attributes means sometimes columns are also called as attributes, okay, that support the compiler in different phases. These attributes are, one is name, so what is the name of the entity that we are talking about, and the other one is size, so what is the size of it, right? What is the size of an int, what is the size of a character, in case if it is an array, what is the size of the array, right? And dimension, so the dimensions are used in case when it is an array, right? If it is not an array, the dimension is generally going to be 0. If it is a single one-dimensional array, the dimension is going to be 1. If it is a two-dimensional array, the dimension is going to be 2, right? And then the type. So type, as you know, it can be either integer or character or any type like that, boolean. And the next one is line of declaration. So this is going to give you the number at which that particular variable is declared. So why is this line of declaration is important is, in case if you have to generate an error saying that some error has occurred, then you should know where that line, where that error has occurred, right? So that is why you should always store the line of where it is declared as well as the line at which it is used, so that later when you are trying to report the errors, you can also give the line at which the error has occurred. So you are going to store the lines. And the next one is address, so address of that particular entity, okay? So this is how your symbol table is going to look like. It is going to contain all these attributes, and depending on the implementation, there might be few more attributes added by some programming languages, and few more attributes may be deleted. But typically this is the information you are going to see in most of the symbol tables, okay? So let's see some example. Let us say name of one variable is one array is Ravi, right? And it is of type character, okay? And let's say it is a array of size 4, so size is 4, and it is a one-dimensional array, that is where dimension is given as 1, and then depending on the line at which it is declared, you are going to get the line number, and then depending on the line at which it is used, you are going to get the line of usage. Sometimes what happens is, you might use a variable or an entity in more than one place, right? Let us say in the program you are going to use a variable I at 10 places, right? And now if you see the line of usage, since it is given as a single field, while implementing it, it will be implemented as a linked list. So since we don't know how many times it is going to be used, it is better you maintain a linked list, and in that linked list, in each node you can save at each point at which, or each line at which it has occurred in the linked list, okay? So you are going to maintain a pointer here, and that pointer is going to point to the linked list in case if a variable is actually declared at more than one place or used at more than one places, right? And address is going to give you what is the address at which this particular variable is stored, okay? Now all the attributes are not of fixed size, so the attributes may be of different sizes. For example, line of usage, it may vary, right? And now what about the size of the symbol table? Again, the symbol table is a kind of data structure. Now you are supposed to find out, or you are supposed to specify how much size you need. So the problem with this one is, just like the declaration of an array, you don't know the exact size that you might need. Now if you try declaring it too small, then it will be giving you advantage in terms of the space saving, but then the problem is you might not be able to store information about too many variables or all the variables. Now in case if you declare it too big, then you might be wasting some time, some space, because after storing the information about all the variables, some of the entries might be left over which will not be used anymore. So that is why it is better if you can use a dynamic allocation of this data structure, of this table, right? So see this limitations of fixing the size. Once you fix the size, there are two problems you might come across it with. So one is, if the chosen size is, if it is chosen small, then it cannot store more variables, It cannot store all the variables which are present in the program. If it is chosen large, a lot of space is wasted. Therefore, so the size of the symbol table should be dynamic to allow the increase in size at the compile time. So you should you should try to allocate this space dynamically. So whenever you need to add more variables, you should keep on increasing the size of the symbol table. So instead of using the static sizes, you better use dynamic sizes. Okay, fine.